Should be live on YouTube. Let's give it a second. This is Edexcel A-level maths. We're 2 days away, guys. 2 days away. Let me know if you guys can see everything on YouTube. I can only see the YouTube chat, guys. I can't see the TikTok chat. So let me know if everything's good on YouTube. Just give me a thumbs up in the chat. Just let me know, let me know. We're going to be going through 5 or 6 questions today. People wanted me to do it on YouTube and not on TikTok. I see Darius is on TikTok. Guys, all the screen sharing will be on YouTube. So let me know if you guys can see my page on sorry Ryan, sorry, we're just trying to get everything set up. Let me know if you guys can see everything. The way we're going to do it today is I'm going to go through the whole question and then I'm going to answer any questions afterwards. I'm going to give people a second. We are doing 5 or 6 questions on YouTube. I can't do it on TikTok, otherwise my laptop will crash. Right, Caitlin says we're all good. I'm going to leave this question up for now. We got a vector question coming on first. I'll leave it up just for a minute while everyone's joining up. Let me know if you guys can see everything. We're live on YouTube, guys. We're going to be going over 5 or 6 questions. 5 or 6 questions today. We're going to start maybe 10 past. We'll see a bit earlier just as people join up. Boys, we're 2 days away from A-level maths. What questions we got? We got vector questions. We got differential equations, trigonometric identities, circles, bit of modulus. So we're going to be going over some key topics that we are going to be seeing in the exam. There's already a vector question up on the screen. It's the first question we're going to be going through. Just going to give it a minute for people to join up. It's all on YouTube, guys. It's all on YouTube. 2 days away from A-level maths paper 1. We're going to start in a minute, guys. We're just going to let people join up. Give people a chance. And always feel free to have a go at the question. Vector questions, we see they come up every single year. There hasn't been a year where we haven't seen a vector question. So you do have to expect this stuff, guys. You definitely have to expect it. Circle questions and vector questions, we see them almost every single year. Here's the YouTube, guys. Link is in the bio. I'm seeing some people join up. Give me a thumbs up if everything's good on the YouTube stream as well. Let me know if anything's too dark, because on my screen it's appearing quite dark. Let me know, let me know. 5 or 6 questions, guys. Today we're going to go through 5 or 6 questions. These are all A and A star questions. All live on the YouTube. All live on the YouTube. What predictions? I'm not going to tell you guys exactly what to revise, but we are going to be seeing integration, obviously. Parametric integration, very, very likely. We haven't seen it recently. Let me know if you guys can see everything. A little dark, a little dark. Kind of dark. Is it too dark? Is it too dark, guys? You know what I might do? I might move my OBS. Is it brighter now, guys? Is the screen brighter now? Let me know if it's brighter or if it's still too dark. We're going to be starting in 5 minutes, guys. Starting in 5 minutes. No, it's not too dark. Don't worry, still see it. It's brighter now? Okay, okay. Like a little? Okay, okay. If I do AQA, yeah. A-level maths revision's A-level maths revision. Definitely helps. No, the same. Guys, should I switch over to TikTok? Or just say, should we just stay on YouTube? I've got everything set up on YouTube currently, but if it's not brighter, okay, okay. Let me know if I should switch over to TikTok, and I will, but let's see if YouTube works better, because I want to get this live stream recorded and straight onto YouTube afterwards. That's the goal. Okay, guys, all the questions are on YouTube. We're doing A and A star questions today. Okay, Caitlin wants YouTube, so we're going to stay on YouTube. Alright, guys. I think we're going to start going through questions now. I'm going to give it a second. We are on YouTube, guys, live on YouTube. Okay, we've got a few concurrent viewers. It looks like we are going to be starting to go through this. Stay. People want me to stay on YouTube. I think people prefer to watch on their computers. So staying on YouTube. Guys, we're starting in 2 minutes. 2 minutes we're starting. Just giving people a chance to see the questions. These are all A and A star questions. I'm gonna keep the TikTok live on just to send people over. If my phone dies, my phone dies. Feel free to have a go at this question I have on the screen, guys, the vector question. So the OBS I might as well move over here then. Okay. Alright. This is an A-star question, guys. Classic vector question. If you were here yesterday, this is a very similar question to what we had yesterday. I hope Bok is here. If Bok's here, let me know, Bok. Because we know he's gonna get that A-star. Bok is always asking for the next question before I'm even finished. Guys, we're gonna start in a couple minutes. We are live on YouTube. Live on YouTube if you want to, link in bio if you want to see me go through some A or A-star questions. We're gonna be starting up very soon, very soon. Alright, boys, I think we are gonna be starting now. Guys, give me a thumbs up if you're ready to go through everything. Give me a thumbs up, thumbs up. So I'm going to go through the entire question at once, and then afterwards I'm going to answer any questions in the chat. The chat is a bit delayed for me, so I won't see things for like 30 seconds, but just give me a thumbs up if you're ready to go. I'm going to be going through the entire question first. I'm going to have to reopen the YouTube chat, guys, sorry. Okay, here we go. I'm seeing thumbs up, so. Alright, there we go. Alright, guys, here we go. Just really put my screen in the corner so you guys can see. There you go. Alright, guys, we're going to start going through this now. Okay. So this is a classic vector question. I'm going to go through the whole thing at once, so let's go. We're told the points A with coordinates -1, 4, B 2, 3, and C 8, 1 lie on the xy plane, where O is the origin. We have to show that A, B, and C are collinear. Now you guys have to know this for your exam. Collinear, all it means is that these 3 points will lie on the same line. So the way we're going to do this question is if we can prove that the vectors A to B and B to C are parallel, this means they're going to be collinear. Because they share a common point B, if A to B are parallel, if A to B and B to C are parallel, and they share that common point B, it means they have to be lying on the same line. So let's go through it. So we have our points A -1, 4, B 2, 3, C 8, 1. To show they're collinear, all we have to do is show that A, B, and C lie on a straight line. To do this, we're going to show that the vector AB and the BC are parallel. Because B is a common point, if they're parallel, they lie on the same line. Just reiterating these key points. So our vector AB, we can just simply see how to get from A to B. So to get from -1 to 2, we have to add 3. And then to get from 4 to 3, we have to -1. If you want to do it formulaically, you can do B take away A. This will give us 3 minus 1. To find our vector BC, we can do C take away B, or think about how to get to C from B. We start at 2, we go to 8, so we're going to have to increase 6 in our x direction, and we go from 3 to 1, so we're going to take away 2 in our y direction. We can quickly see that our vector BC is a scalar multiple of our vector AB. Remember, if one vector is a scalar multiple of another, these vectors are parallel. So because BC is 2 times A to B, one is a scalar multiple of the other, they're parallel, and because as we've established, if these two vectors are parallel, it means they're going to be collinear, lying on the same line because of that common point B. Let's move on to part B here. So in part B, we're told that a point D lies on BC such that the vector BD, or the ratio of the vector BD to the ratio of BC, is 2 to 3. Okay, guys? So in these vector questions, we're always going to want to draw a diagram out. So that's the first thing we're going to do. Now, drawing a diagram out, kind of think about the points we have. But all we know is we go from O to B. B is 2, 3, so you can kind of imagine we go 2 to the right, sorry, and then 3 up. As our x value is 2 and our y value is 3. So we can draw on B. We know C is going to be 8, 1. We go 8 to the right and 1 up. And we know D will be at some point along there. We know our vector BD to our vector BC is at a ratio of 2 to 3. Okay? We use the coordinates to draw a diagram. So we know this ratio here. This means if we start at B, D is 2/3 of the way to C. Because the whole thing is 3 parts, and B to D is 2 parts of the way there. Okay? So starting at B, D is 2/3 of the way to point C. So to find the coordinates of D, first of all, we're going to find B to D. We know BC from part A is 6 minus 2. Yeah, we have to increase our x value by 6 and decrease our y value by 2, right? We know that BD, as we've established, is 2/3 of this. So we multiply our 6 minus 2 by 2/3. Because we see to get to D is 2/3 of the way, all the way from B to C. So we do 2/3 multiplied by 6 minus 2, because we established that BC is 6 minus 2 in part A. 2/3 times 6 is 4. 2/3 times -2 is -4/3. We now have BD, but they don't want BD. They want us to find the coordinates of D. So what we're going to do is we have to go O to B and then B to D. Now we know from O to B, because we have the B coordinates to be 2, 3, we do 2, 3 plus our vector B to D. So 2 plus 4, that's 6. 3 plus -4/3, so that's 3 minus 4/3 is going to be 5 over 3. Okay? So we know our D coordinate will be 6, 5 over 3. And that's part B of this vector question. Now let's move on to part C. Remember guys, because they give us the coordinates, we can do a rough drawing. Your drawing does not have to be perfect, it just is always key to visualize these things. So for part C of this question, the straight line OB is extended to the point P, such that AP, our vector AP, is parallel to OC, okay? We have to determine the coordinates of P. Now whenever we have this new unknown point, which is an extension or halfway or some way along some line, we're always going to set up simultaneous equations, okay guys? So setting up simultaneous equations, we're going to determine the coordinates of P. So let's scroll down. This is the key one where you would want to draw that diagram, just to get a good idea. So drawing out, we know that our point P will be an extension of O to B, because we're told, once again, looking back at the question, we're told that OB is extended to the point P. Furthermore, we know from part A that A, B, and C are collinear. They're all going to lie on that straight line. So more or less, just using the coordinates that they give you, we know that A is at minus 1, 4, so it's going to be the furthest to the left and the highest up. B is 2, 3, so it's going to be 2 to the right from the origin and 3 up. And then C is going to be furthest to the right because it's 8, 1. So it's going to be furthest to the right and only 1 up, okay? So we know these all lie on the straight line and we can make a rough diagram. We can more or less draw it out because we know they tell us in the question that our vector A to P is parallel to O to C. So we can more or less draw our P such that A to P is parallel to O to C. All of this is just to help you visualize this. Now the key thing is we're going to find two paths to get to P. Let's write down what we know. With vector questions, we always just want to write down what we know at the top so we know what we're working with as we're going through the question. Okay? So our vector O to B is 2, 3 as we're given the coordinates. O to C is 8, 1. Now remember, as we know that P is on the same line as our vector O to B, we know it's going to be our vector O to B extended. So it's our vector O to B times by some constant, a little bit more. It could be 1.5, it could be 2, it could be 3, we don't know. But we're going to call that constant lambda. So O to P will be lambda times O to B, an extension of our vector O to B. We're going to find the second way to get to P. With these questions, they always want you to find two routes to get to your unknown point. So vector questions, classic simultaneous equations, in order to find where your unknown point will be. It's a classic way of asking the question. So to find the second way, we have to use information that we know. We know O to A. So looking at our diagram, we can clearly get from O to A because we know the coordinates of A to be minus 1, 4. Perfect. And they give us this information for a reason. We know our vector A to P is parallel to O to C. And what do we know about parallel vectors? One will be a scalar multiple of the other. A parallel vector will be a scalar multiple of the other, right? So because we know A to P is parallel to O to C, all we're going to do is multiply our vector O to C by some constant. We don't know what it is, we're going to call it mu. So scrolling down, we know to get to P, we can do the vector O to A plus the vector A to P. Or we can rewrite this vector A to P because it's parallel to our vector O to C as O to A plus mu times O to C. And exactly as I've written down here, guys, we set A to P equal mu OC. Remember that mu is just some constant. Do not get intimidated by the Greek letters. It's just some constant. And we're using this because A to P is parallel to O to C. So now we know these two things are equal. These are both different ways to get from O to P. So we can set lambda times O to B equal to O to A plus mu times O to C. We found two different routes to get there. So we set them equal and we plug in what we know. We know O to B is 2, 3. It's all given in the question. We know O to A is minus 1, 4 using the coordinates of A. And then we know O to C is 8, 1. So we just plug in all the values we know into this simultaneous equations. Or not yet, we're going to make the simultaneous equations. So basically, for the simultaneous equations, we compare the x coordinates and the y coordinates. Remember, everything at the top is telling us how much we're shifting on the x's, and everything on the bottom by the y's. So therefore, 2 lambda will have to be equal to minus 1 plus 8 mu. And then looking at the y's, we have that 3 lambda will have to be equal to 4 plus mu. Okay, guys? So this is just GCSE simultaneous equations. All we have to do, the way I did it, you can do this however you want, it's just solving simultaneous equations. I decided to multiply this bottom equation here by 8. 3 times 8 is 24, 4 times 8 is 32, and mu times 8 is 8 mu. Here we can see our 8 mu's will cancel out, taking equation 1 away from equation 2. So we have 8 mu minus 8 mu, those cancel out. 32 minus minus 1, that's 32 plus 1, which is 33. And then we have 24 lambda, take away 2 lambda. This leaves us with 20 lambda equals 33. divide the right-hand side by 22. We have lambda equals 33 over 22. 33 over 22 is just 3 over 2. So we have lambda equal to 3 over 2. Let's quickly recall what lambda is. We said that O to P was lambda times O to B. Therefore, now that we've found lambda, we know that O to P is lambda times O to B. Saying it again, plugging in lambda, which we now know to be 3 over 2 after setting up simultaneous equations using two roots to get to P from O. We know we do 3 over 2 multiplied by O to B. Once again, they give us the coordinates of O to B to be 2, 3. So we do 3 over 2 times 2, 3. 3 over 2 times 2, that's just 3. 3 over 2 times 3, it's 9 over 2. That's exactly our coordinates for P. So that's the vector question, guys. Put anything in the chat. Put anything in any questions in the chat, guys. That is the vector question. So it's all in one chunk if you want to rewatch this. Okay, looking at the questions here. This will be available on YouTube after, guys. Will be available on YouTube. If the ratio is 2 to 3, surely it's 2/5 and 3/5. No. Let's look at the question carefully, guys. B to D compared to B to C is 2 to 3. So they tried to trick you here, yeah? They're not telling you that B to D to C is 2 to 3. It's telling you that the whole vector, B to C, is at 3 parts. And that vector B to D is 2 parts. Try to think about it. Let me scroll down and compare it to our diagram, okay? Oh, sorry, wrong bit. Okay. So our B to D to B to C is 2 to 3, okay? So the whole way is 3 parts. And to get to from B to D, this is 2 steps of the way there. Does that all make sense, guys? Give me a thumbs up in the chat or a thumbs down. Does that make sense? I'm not sure if my chat is lagging. Does that make sense, guys? Does that make sense? You know what, boys? I'm gonna try stream as well on TikTok. If you guys are, if you guys want to watch on TikTok, see if this works. Apparently, I have to go live for 1 more minute. Okay, Harris says he's happy. Is everyone happy with this question? While can you use gradients for part A? I mean, all we're showing is the two vectors are parallel in order to show the collinear. It's the best way to do it, to be honest. Like the way I'm doing this is just the fastest way to do it in the exam. I mean, I guess it would be the gradient, but I mean, the key bit of information we're using for these vector questions is that parallel vectors are scalar multiples. That's all we have to show. I'm seeing some thumbs up. Yeah, be careful with that ratio question, guys. They won't always ask it in the same form every time. So in the past paper, they didn't ask it in this way, and your instant reaction is to think 2/5 and 3/5. We're gonna go on to the next question, guys. I'm gonna leave it up for a second in case you guys have any more questions. If you have any more questions, guys, let me know. We are 2 days away. I'm now gonna try and stream on TikTok as well. We'll see if my computer blows up. Just opening up TikTok, guys. Seems like you guys are happy. The next question is on the screen if you guys want to have a go. Just opening up TikTok Studio. Not sure if this will run, but we'll give it a go. Live stream will be available on YouTube after. Let me know if you guys have any questions. But the next question is already on. We have a trigonometric identity question. This live stream will be available on YouTube after. Not sure why it's doing that to me. Oh, that's annoying. Sorry, guys. It's not cooperating right now. Right, looks like we're just gonna have to go back on the phone. I apologize for anyone watching on YouTube. Just give me a second, guys. How are we feeling about A-Level Maths Paper 1? Coming very, very soon. Very, very soon. All right. Sorry guys, just got to promote the YouTube on the TikTok. Okay. Alright guys, next question. I'm gonna go through it all at once, and then if you have any questions, I'm gonna go through it after. Sorry, answer any questions after. So trigonometric identities, nothing too bad. We're told that sine A plus B is equivalent to sine A cos B plus cos A sine B. This is just the addition formula that you need to be knowing by now, guys. We have to use this above trigonometric identity to show that sine 3x is equivalent to 3 sine x minus 4 sine cubed x. Okay? So this question is even friendlier, guys, because they give you this addition formula. You don't even have to figure it out yourself, okay? So I'm just going to go through the whole question, guys, and I'll answer any questions after. So we have to show that sine 3x is equivalent to 3 sine x take away 4 sine cubed x. We're given this trigonometric identity, so the first thing we're thinking is we're going to have to write that sine 3x differently. We're going to write it as sine 2x plus x. Otherwise, why else would they give you this trigonometric identity? So writing it as sine 2x plus x and using the fact that sine A plus B equals sine A cos B plus cos A sine B. So we have sine 2x multiplied by cos x plus cos 2x multiplied by sine x. Okay, guys? But then from here, we see that the thing we're trying to get to on this right-hand side only has single x's. There are no two x's, okay? So because there's no two x's, we're going to have to use the sine double angle ID and the cos double angle ID, okay? So using the sine double angle ID, we know that sine 2x is equivalent to or equals 2 sine x cos x. And look at what we're trying to get to, guys. We're trying to get to 3 sine x take away 4 sine cubed x, okay? Because everything here is in terms of sine, the form of the cos double angle ID we're going to use is 1 minus 2 sine squared x, because our answer is in sine as I've written in the document. So using these double angle IDs, we have that sine 2x is 2 sine x cos x, and then we have that cos 2x is 1 minus 2 sine squared x. Multiplying them out, we have 2 sine x, cos x times cos x is cos squared x, and then we have sine x times by 1, it's just sine x, 2 sine squared x multiplied by sine x, we have minus 2 sine cubed x. Now remember, everything is in terms of sine, so we're going to do cos squared x is equivalent to 1 minus sine squared x, because we know our trigonometric identity of cos squared x plus sine squared x equals 1. Okay? So we made that substitution in for our cos squared x. So we have 2 sine x multiplied by 1 minus, it's not letting me scroll down, by 1 minus sine squared x. Okay? So after making this substitution, what we're going to do here, expand on the brackets. So 2 sine x times 1 is just 2 sine x. 2 sine x times by minus sine squared x. That's going to be minus 2 sine cubed x. Document's not letting me scroll down. Give me a second, guys. Okay. So we have 2 sine x minus 2 sine cubed x plus sine x. So we have 2 sine x plus sine x. That's going to be 3 sine x. Then we have minus 2 sine cubed x minus another 2 sine cubed x. That's going to be minus 4 sine cubed x. So we've shown the left-hand side is equivalent to the right-hand side. Easy as that. Now let's look at part B. Remember, in part B of these trigonometric identity questions, they're normally going to want you to use what you found in part A. So even if you can't get part A, you can do part B. So for part B, they want us to find the integral, indefinite integral, no limits. We're going to need that plus c at the end. Remember that when you see an indefinite integral. So we have the indefinite integral of cos x multiplied by 6 sine x minus 2 sine 3x, all to the power of 2/3. And naturally, we're integrating with respect to x. Okay? So in these questions, normally your part A will be times by 2, times by 3, or it might be rearranged potentially. It will look a bit weird in the part B. But here, luckily, the only thing we need to substitute in part B is sine 3x, okay? So we're going to substitute in sine 3x, okay? So we know, excuse me, we know that sine 3x is equivalent to 3 sine x minus 4 times sine cubed x, okay? So because we know this, we're going to make that substitution. So let's scroll down. Apologies. So we're going to make the substitution for sine 3x. We're using part A, that sine 3x is equivalent to 3 sine x minus 4 sine cubed x. We plug it in. So plugging it in, let's expand out these brackets here. Minus 2 times 3 sine x, that's going to be minus 6 sine x. Minus 2 times by minus 4 sine cubed x, minus times a minus, is going to be plus 8 sine cubed x. Now we can see within our brackets, this 6 sine x will cancel out with the minus 6 sine x. So we're left with 8 sine cubed x to the power of 2/3 in our brackets, okay? 8 sine cubed x to the power of 2/3. Well, 8 to the power of 2/3, we cube root it to get 2, and we square it to get 4. sine cubed x, we cube root it to get sine x, and then we square it to get sine squared x. So we have the integral of cos x multiplied by 4 sine squared x. Okay? Remember, guys, whenever we see sine to the power of something multiplied by a singular cos, instantly thinking reverse chain. Because remember, when we're differentiating sine, we're going to bring that power down to the front, take one away from the power, and multiply it by cos x. Okay, guys? So from here, we're thinking reverse chain rule. We have sine squared x, so we're going to make an educated guess. That's going to be sine cubed x. All we have to do now is differentiate sine cubed x and compare it to what we had in this interval. Differentiating sine cubed x, as I said, bring that power down to the front, take one off the power, and multiply it by sine x, the thing inside our cubed, multiply it by sine x, multiply it by sine x differentiated, that's going to be cos x. So we have 3 sine squared x times cos x. Now we have to compare it to what we had in our interval. We had 4 cos x sine squared x. To get from 3 sine squared x to cos x to 4 cos x sine squared x, we have to multiply by 4 over 3. Think of it as divide by 3 and then times by 4. And then, of course, indefinite integral, I maybe would write that all at the end, sorry, already at the end, at the very start of the question, you add in that plus c, indefinite integral, no limits. And that's the end of this question, guys. Nothing too tricky. Put any questions that you have in the chat. I'll leave the next question already on. There's a predicted paper question. Mr. Asprey, shout out Mr. Asprey. If you guys have any questions, let me know. Can you scroll back for the answer for part A? I'll scroll back to the answer for part A, I got you. Part A was just seeing that we had only signs and single x's. Can you explain the second last line again? I will in a second. I'll leave part A up for just 5 more seconds. And then we'll go on to that last part of part B, okay? Guys, join the YouTube. Just gonna see how many viewers we have quickly. Okay, perfect. Let me know if that makes sense, guys. Okay, I'm gonna go down to part B. The second last line, because we had sine to the power of something multiplied by a singular cos x, we're thinking reverse chain rule. Because we know that sine, cubed x, the 4x, the 5x, whatever it is, we bring that power down to the front, take one away from the power, and then multiply it by sine x differentiated, which is cos x. So whenever we see this, we make an educated guess. In this case, it's going to be sine cubed x, add 1 to the power essentially of that sine squared x. We compare it to what we had in the integral, and then we multiply as necessary to get the appropriate answer, which would be 4 over 3 sine cubed x. Because we had that 3 sine squared x cos x, but we originally had 4 cos x sine squared x, we would have to multiply our original guess by 4 over 3 in order to get that. Guys, give me a thumbs up if we're happy to move on. Give me a thumbs up if we're happy to move on. Guys, we are live on YouTube. We are live on YouTube. Any more questions, let me know. How many questions? We're going through 6 questions. We've done 2 questions. We're going through 4 more. Link in bio, guys. Link in bio. 6 questions today. I'm not sure if the chat is slow, but Kaden seems happy to go on. I think we're happy to go on, guys. Okay, I've seen 2 thumbs up. I'm with 3 now. Okay, cool. Alright, perfect. We're going to move on, guys. I'll leave the question up for a second. And then once again, are you guys happy with me? Are you happy with me going through the whole question first and then any answers? I'm just trying to keep it fast paced for when people rewatch it, they can kind of see me explain it all at once. I don't have a time when this will end. I have 4 more questions to go through. We've done 2, we're going to do 4 more. Okay? Just trying to help you guys out. Looks like we're happy with the format. Looks like we're also happy with the format. I think my chat is delayed, guys. It takes me a minute to see things. Sorry. We're live on YouTube for anyone on TikTok. I hope that all makes sense, guys. I hope that all makes sense. I'm seeing a bunch of thumbs up. Looks like we're going to start going through this question. Okay. So guys, differential equations and partial fractions, an incredibly key topic in your A-levels. This is inevitably going to come up. It's inevitably going to come up. Okay, guys? So let's go through part by part. I'm going to go through the whole question so the recording looks good. Okay? Alright. So part A. We have to write 1 over h minus 5 multiplied by h plus 3 in partial fraction form. Okay, we're going to ignore the rest of the question, just do part A. So writing this in partial fraction form, we know this will be in the form of a over h minus 5 plus b over h plus 3. So we know with partial fractions, we're going to multiply the whole thing through by h minus 5 and h plus 3. That will leave us with a times h plus 3 plus h minus 5 times b equal to 1. That's all we're doing in this step. Now remember, we want to eliminate our a's in order to find b and eliminate our b's in order to find a. So first we're going to plug in h equals 5. Okay, guys? So plugging in h equals 5, we look at our b part or our b component. 5 minus 5 is 0. 0 times b, we ignore that. Plugging h equals 5, we have 5 plus 3, which is 8. We have 8 times a equal to 1. Therefore, divide over by 8, we have a equal to 1 over 8. Now we do the other side essentially. We're going to plug in h equals minus 3 to eliminate that a component and isolate the b. Okay? So plugging in h minus 3, we see the a component will be 0. Minus 3 plus 3 is 0. So we have 0, 8. We can ignore that. And then we have minus 3 minus 5. That's minus 8. So we're going to have 1 equal to minus 8b. Therefore, divide over by minus 8, we have b equals minus an eighth. And remember, this is a key part of partial fraction questions. You always have to write out your final fractions. They're not happy if you just find values of a and b. You do have to write out that final answer. So we say 1 over h minus 5 multiplied by h plus 3 equals 1 over 8 over h minus 5. Take away 1 over 8 h plus 3 because we had that b is minus an 8. So we're taking it away. On to part b, guys. So a bit of waffle here, 7 marks in this paper. It seems a little bit too much in my opinion, but let's go. The depth of water in a storage tank is being monitored. The depth of water in the tank, H meters, always underline in units, guys. The units are very, very important in these questions. H meters is modeled by the differential equation, dH dt. Also, we're very lucky, they've already told us it's a differential equation question. dH dt equals negative H minus 5 multiplied by H plus 3. Okay? And that's a negative all over 40. But these are time in days. Once again, guys, underline those units. They like to switch it up throughout the question. So T is the time in days from when the monitoring began. Given that the initial depth of water in the tank was 13 meters, so the initial depth of water. So when T equals 0, we know the height was 13. We have to solve the differential equation to show that H equals 10 plus 3e to the minus 0.2t all over 2 minus e to the minus 0.2t. Okay? So they told us this differential equation already in this question, but whenever they give you values, like in this case t equals 0, h equals 13, we can already suspect it's going to be a differential equation question, so we're going to find that constant of integration. That's the key part, okay? So let's solve the differential equation. So we know when t equals 0, h equals 13. With differential equations, we want all of our t's on one side and all of our h's on the other. So we can divide over by h minus 5 and divide over by h plus 3. Furthermore, we already split this up into partial fractions in part A, so it seems like the obvious thing to do. We're also going to multiply over by dt because we want all of those t's on one side. So we get all the h's on the same side and all the t's on the other. So we have 1 over h minus 5 multiplied by h plus 3 dh integrating with respect to h equals minus 1 over 40 dt. Okay? First thing we're going to do, we're going to rewrite from part A as partial fractions. Okay? So we're using part A, we're going to rewrite that 1 over h minus 5 h plus 3 as 1 over h minus 5. I know we had 1/8, guys, but I've decided to factor out that 1/8 out of the integral. I'm going to explain why in a second. We have 1 over h minus 5 minus 1 over h plus 3 equal to the integral of minus 1 over 40. The reason we can factor out that 8, guys, is we can multiply both the left and the right by 8 to make things a little bit easier, and you will see this will actually get us the answer we need. So we factor out the 8th, multiply everything by 8. So we have the integral of 1 over h minus 5, take away 1 over h plus 3, dh equal to the integral of minus a fifth dt. So nothing too bad on the right hand side, integrating minus a fifth with respect to t, just going to be minus 2 over 5 or minus a fifth times t. And then integrating our h side, remember if we have some function of x and that function of x differentiated on the numerator, so our function of x, or in this case h, is h minus 5. Okay, h minus 5 differentiated, the h differentiates to 1 and the constant disappears. 1 is exactly what we have on the numerator. So this will be the natural log of h minus 5, looking at the fraction on the left. And then for the negative of 1 over h plus 3, it's just going to be minus natural log of h plus 3. This will be equal to minus t over 5 plus c. Remember, we would normally have, with two indefinite integrals, constants of integration on both sides. We can combine them into one constant on the right-hand side, okay? So from here, A-level maths, we're thinking log rules. I'm seeing two logs. Log A take away log B. It's the same as log A over B. So that's what we're going to do, okay? So we have, combining these logs, the natural log of h minus 5 over h plus 3. and this will equal minus 0.2t plus c. So this is great. From here, we're going to use the values they gave us. We know that when h equals 13, t equals 0. So we're going to be able to find that constant of integration. So from here, we sub in h equals 13. 13 take away 5, that's 8. 13 plus 3 is 16. So we have the natural log of 8 over 16. Minus 0.2t, plug in t equals 0. That disappears, minus 0.2 times 0, that's all 0. So we have the natural log of 8 over 16 equals our constant. 8 over 16 is just a half. So our constant is the natural log of a half. All right, great guys, we've got the constant of integration. We are going to carry on from here. So we have the natural log of h minus 5 over h plus 3 minus ln of half equals minus 0.2t. The reason we take away that log, because we have that c on the right hand side, we're now going to take away that minus ln of a half. The reason we're doing this, once again, log rules, we can combine these logs. Log a minus log b is log a over b. So we're going to do h minus 5 over h plus 3 divided by a half. Dividing by a half is the same as timesing by 2. So as I've said here, use the rules of logarithms to combine. Subtracting logs means we divide the inputs. So multiplying h minus 5 over h plus 3 by 2, we have 2h minus 10 over h plus 3. And this will be equal to minus 0.2t. Now all we have to do is make h the subject of the formula. Because remember, let's go back to the question. They want it in the form of h equals something. Okay, all of this mess here. So we have to find that mess. The reason we wrote minus t over 5 as minus 0.2t is because we saw in our answer they wanted it as minus 0.2t. That's just an explanation of why we're doing each step. So from here, we're going to take the e of both sides because we want to get rid of that natural log. So we have 2h minus 10 over h plus 3 equals e to the power of minus 0.2t. From here, we're going to multiply over by h plus 3. Expand out the brackets, we have h e to the minus 0.2t plus 3 times e to the minus 0.2t. Remember, we're trying to make h the subject of this formula, okay? So we're going to take away that h e to the minus 0.2t, and then we're going to add over 10 to the right-hand side, okay? So from here, guys, we're going to factor out that h on the left-hand side, because remember, h subject of the formula. So we have h times 2 minus e to the power of minus 0.2t equals 10 plus 3 times e to the minus 0.2t. Therefore, last step, as required, we divide over by 2 minus e to the minus 0.2t. So h will equal 10 plus 3 e to the minus 0.2t over that 2 minus e to the minus 0.2t. Exactly as required. Now moving on to part C. So part C of this question, nothing too tricky. We have to find the time taken for the depth of water in the tank to fall to 8 meters. All we have to do, guys, height of the tank, 8 meters. Luckily, we've already been told that our height is in meters. Remember, always underline those units. Here, they may have given you something in centimeters. Luckily, they've kept the units consistent. But watch out for that in the exam. So we plug in h equals 8 and we find t. This is GCSE rearranging. It's a little bit annoying, but let's do it. Sorry here. So we're going to plug in h equals 8 in order to find t. So we have 8 equal to all the mess that we had before in part B. We're going to multiply over by 2 minus e to the minus 0.2t. 2 times 8, that's 16. 8 times minus e to the minus 0.2t is minus 8 e to the minus 0.2t. This will be equal to 10 plus 3e to the minus 0.2t. Okay? So from here, we're going to want to get all of our t's on one side because by the end of this, we want t equals something. Okay? So we're going to add over 8 times this e to the minus 0.2t plus the 3 times e to the minus 0.2t. 8 plus 3, that's just 11. Okay? We have 11 e to the minus 0.2t on the right. We're going to do 16, take away 10. 16 minus 10, that's just 6. So we have 6 equals 11 times e to the minus 0.2t divided by 11, 6 over 11, because remember, we're making t the subject. So we're going to divide over by 11. 6 over 11 equals e to the minus 0.2t. Take the natural log of both sides to get rid of that e. So we have ln 6 over 11 equals minus 0.2t. Then we're going to divide by minus 0.2. Dividing by minus 0.2 is the same as timesing by minus 5. Plug it in your calculator. Minus 5 times ln 6 over 11 will equal t. This will give you t to be 3.03 days. I've emphasized here, use the units, guys. Use the units. That's an extra mark. If you don't put it, you lose a mark. And then remember, we are going to be underlining t is the time in days at the start of the question. Now moving on to part D, we're told that according to the model, the depth of water in the tank will eventually fall to k meters. Eventually fall. What does this mean, guys? We're going to have to plug in a really, really big value of t. or just think as t tends to infinity. So after many, many days pass, what will h be? Luckily, we've already been given this equation for h, so we can just plug in really, really big numbers for t, or just think when t tends to infinity. That's what we have to do. Let's scroll down. So looking at part D, we're checking as t tends to infinity. Now there's two ways you can do this. You could just plug in large values and it will give you an approximate value of 5 meters, and that will be your final answer. If you're panicking in the exam and the adrenaline is pumping, that might be the easiest thing to do. The way I would do it, especially doing a maths degree, this is the first thing I would think of doing. I quickly draw that E graph out, okay? And I think what happens as t tends to infinity, or a really, really large number. So as t gets really, really positive, we're going to be multiplying that really large positive number by a negative number. So we're going to be plugging in a really, really large negative number, or a really small number, I guess, into our E graph, is the way to think of it. Looking at our E graph, we can see as we plug in a really, really negative x value, we have something that is arbitrarily close to zero, basically zero, okay? So we have e to the minus infinity, this tends to zero. Leaving us, let's look at our expression once again. So we now know that all of our e's will essentially equal zero, right? So we have 10 plus 3 times 0 is 10. 2 minus 0, it's going to be 2. So we're left with 10 over 2, which gives us that final answer, exactly what we were looking for, of 10 over 2. So k will be 5 meters. That's that differential equation question, guys. I'm going to give you guys a second, ask any questions in the chat. Just going to see how things are going. We'll take that. Let me know if you guys have any questions about that. Any questions, any questions? We are almost 1 day away, guys. Almost 1 day away. Almost 1 day away from A-level maths. You have one more sleep where you can wake up relaxed, and then it's a little bit stressful. 1 day away, guys. 1 day away. Let me know if everything's all good, guys. If you have any questions. Not sure if the chat is slow or if it's just everyone's happy. Give me a thumbs up if you're happy, or give me a question if you have any questions. So let me know, guys. Let me know. I'm always worried my chat is freezing. Ryan says, "My God." Not sure if that's a good thing or a bad thing. Let me know if you have any questions, or thumbs up if you want me to continue, guys. Thumbs up if you want me to continue. I'm seeing a thumbs up. I'm seeing a thumbs up. 2 thumbs up. 2 thumbs up. We got a circle question next, guys. I would say this is an A-star circle question coming next. Seeing a few thumbs up. Seeing quite a few. People are happy. People are happy. Decent amount of thumbs up. Decent amount. Next 3 questions, we have circle, we have more trig identities, and we have modulus with a set notation at the very end. So if you're not interested in circles, modulus with set notation, or trig identities, I apologize, but those are the next 3. Seeing a lot of people happy. You do need to know how to integrate a to the x. You do need to integrate. You do need to know that. I'm seeing most people are happy for me to continue on. I'm going to leave this question up for a second. Tempted to try to get the TikTok on. Tempted to try. I'm going to try, guys. I'm going to try. I'm going to leave this question up just for a second. Am I going to do proofs? You know what? I'll do a few proofs. I'll do a few proofs. Maybe not today, but tomorrow. I'll get some proofs ready. Because I'm trying to get the TikTok up and working. I apologize already. Just going to make sure my laptop breathe a bit. Okay, the question is up, guys. Just give me a minute. We definitely have domain and ranges coming tomorrow. Quite a few domain and ranges. Question is up, guys. Question is up. Okay, I'm going to end the live on TikTok and try to put it on my computer. Okay. Sorry, guys. We're setting up everything on TikTok. Set up everything on TikTok. Feel free to have a go at this. Feel free to have a go at this question, guys, as I'm getting this on. Feel free to have a good question, guys. It's a pretty good circle question. Let me know if you guys know the key idea of what we're gonna have to use. What key thing are we thinking when we see this question? What key thing are we thinking, guys? Key thing are we thinking? I think we're also live on TikTok. Should be live on TikTok now with the questions. See if my computer can run it, but because what are we thinking when we see the circle question? YouTube chat's really delayed. Okay, we should be good. Should be good. All right, guys. We have a circle question, an AA star circle question. See if everything's good. Looks like everything's good. A bit on TikTok, a bit on YouTube. If I crash, guys, it's because my laptop is rubbish. I'm gonna leave this question up just for a minute longer. I think it's quite a good question. I'll read it out. Just giving the people a second to join up on TikTok. Center radius. Not quite, guys. Not quite. Not quite. Center radius. Not quite. Not quite. That's not how I'd approach it, to be honest. To be fair, you could probably figure it out. You could probably figure it out like that. I'm gonna show you a quicker way to do it, in my opinion. And I'm also actually gonna show you guys the wrong way to do this. Yeah, the wrong way to go, and how you shouldn't panic if this is the case in the exam. If you start going that way in the exam, don't get stressed. Okay. So we have the circle question. We're told a circle has equations. A circle has equations. Sorry, implicit differentiation. No, no. So we're told the circle has equation x squared plus y squared plus 4x plus 12y equals minus 23. Okay. The lines L1 and L2 are both tangents to the circle. I'm seeing tangent. There's going to be one root, right? If a line is tangent to the circle, there's going to be a single root. When we're thinking roots, I already know what's going through your head. They're both tangents to the circle and they intersect at a 0.550. I'm going to go through the whole question now, guys, just so the recording will look good. Let's go. Okay. So we have two lines. The lines L1 and L2 are both tangents to the circle and they intersect at a 0.50. We have a little diagram here. We have to find the equations of L1 and L2, giving our answers in the form of y equals mx plus c. Now, first thing I'm thinking, let's try and build equations for L1 and L2, just from what we know. Because we're already told they cross the 0.50. That's already something we can use. So from here, we're going to use our straight line equation of y minus y1 equals m times x minus x1. We know our y1, our y value given, is 0. And the x1 value, or the x value given, is 5. Okay? I'm seeing some good stuff. So for L1 and L2, right? We use a known point. So we have y minus 0 equals m times x minus 5. We're going to expand that out. So we're going to have y equal mx minus 5m. Okay? So from here, we're going to substitute this into the circle equation, right? Guys, this is actually the wrong way to do this question. It's not the wrong way, but it's not an easy way. And I'm going to go back to this point further on in the question, and we're going to understand what we can do and why we shouldn't panic in the exam, okay? So we're going to substitute this in the circle equation. So this is what we have for y. So plugging in mx minus 5m in all of our y's, we have x squared plus mx minus 5m squared plus 4x plus 12 times, same thing, mx minus 5m equals minus 23. From here, expanding out that mx minus 5m squared, we have m squared x squared, we have minus 5m squared x, we have two of those, so it's going to be minus 10m squared x, then minus 5m squared is 25m squared. So plus 25m squared, add the 4x, 12 times mx, 12mx, 12 times minus 5m is minus 60m, equal to minus 23. Okay, guys? Then from here, we're going to collect like terms. So looking at x squared, so we're going to have 1 plus m squared x squared. Looking at all of our x's, we're going to have this. Be careful here when collecting like terms. We're going to have 4 plus 12m minus 12m squared. Okay? And this will all be x. We have 4 plus 12m minus 10m squared, x. Then looking at just our constants that don't have x in them, we have that 25m squared, we have that minus 60m, and then we're going to add over 23, because remember, when we're going to be using the discriminant, that's what we're going to be doing here, guys. We add over the 23, and we set this equal to 0. Now, the key thing that we see, exactly, the key thing that we see is we're going to use the discriminant. And it's going to be equal to 0. Because remember, when a line is tangent, in this case to the circle, there's going to be one root, one intersecting point, one point where they touch. So we set the discriminant equal to 0. Okay? This is b squared minus 4ac. Now the key thing to see Exactly, this way is horrendous. This way is horrendous because we set y equal to something. So that's exactly what I wrote here. This is difficult here. So what we're going to do is we're going to try substitute something in for x instead. So rearranging our original equation of y equals mx minus 5m, we're going to set x the subject of a formula. Add over 5m and divide by m. So we're going to have y over m plus 5m divided by m. It's just going to be 5. So we have x equal to 1 over m y plus 5. So from here, we substitute in this back into our circle equation, 1 over my plus 5 for all of our x's. So substituting this in, we have 1 over my plus 5 all squared. 1 over my squared is just going to be 1 over m squared y squared. 5 times 1 over my, we have 2 of those, so it's going to be 10 over my. 5 squared is just 25. Then we're going to be adding y squared. Then we're going to have 4 over my plus 4 times 5, that's plus 20, plus 12y. And then once again, with the discriminant and quadratics, we set it equal to 0. So we're going to add over 23. Here, we're going to collect like terms. Collecting like terms, we have that 1 over m squared on the y squared, and we also have that plus 1. So it's going to be 1 over m squared plus 1 y squared. And then just looking at our single y's, we have 10 over my plus 4 over my. That's going to be 14 over my. And then looking at that 12y here, it's going to be 14 over m plus 12y, factoring out that 1. Then looking at our constants, we have 25 plus 20, that's 45, plus 23 is going to be 68. So plus 68 equal to 0. Now we want b squared minus 4ac equal to 0. Because when we have a tangent to the circle, one point where they touch, a single root. So b squared minus 4ac will be equal to 0. So our b will be 14 over m plus 12. We're going to square that. We have 4 times a, which is 1 over m squared plus 1, and our c will be 68. So 14 over m plus 12 squared, or 14 over m squared, that's 196 over m squared. 12 times 14, I'm going to have to scroll down for this one. 12 times 14, we have 2 of those. That's going to be 336 over m. And then 12 squared is just 144. And then we're going to be taking away 4 times 68. Sorry, let's do it like this. 4 times 68 is 272. 272 times 1 times minus 1, sorry. Sorry guys, 4 times 68 is 272. We multiply this by 1. So we have minus 272 times 1, that's minus 272. Plug this in your calculator. 4 times minus 4 times 68 times by 1 over m squared is just minus 272 over m squared. Okay, so we have this great equation here. Now we can combine terms. We have 196 over m squared, take away 272 over m squared. This is minus 76 over m squared. Then just what we have over m, this is plus 336 over m. And then looking at our constants, we have 144 minus 272. That's just going to be negative 128. This is a hidden quadratic. If we make the substitution, x equals 1 over m, we can rewrite this as it would be minus 76 over x squared. We're going to multiply the whole thing by minus 1 just to make our lives a little bit easier because we always want that thing squared to be positive. It always helps out in these kind of questions. Okay, so we multiply the whole thing by minus 1. Then we make the substitution, x equals 1 over m. We have to spot this hidden quadratic here. So we have 76x squared minus 336x plus 128 equal to 0. From here, just plug this in your calculator, you get 2 roots. You get x equals 4 and x equals 8 over 19. Okay, but remember, our x value, or the value we used, is equivalent to, or sorry, equal to 1 over m. So we have 1 over m will be 4, and 1 over m will be 8 over 19. We don't want 1 over m, we want m. M will be equal, so we find the reciprocal of both sides. M will be equal to a quarter, and m will be equal to 19 over 8. So this is great. We found 2 possible solutions, and these 2 solutions will be the gradients of our lines L1 and L2. Amazing. So all we have to do is plug these back into our original equation. We had y equals m x minus 5. So plugging in a quarter and plugging in 19 over 8, L1 will be y equals a quarter x minus 5 over 4, and L2 will be y equals 19 over 8x minus 95 over 8. And these are your 2 equations doing it this way. Let me know if that makes sense, guys. I'm going to answer any questions now. Just wanted everything to be together. We are live on YouTube, guys. We are live on YouTube, and the recording will be available after, okay? And if you subscribed, if your videos were helpful or the streams are helpful, subscribing will be... I'll be infinitely grateful if you subscribe. Let me know if everything makes sense, guys. Let me know. I'm reading the YouTube chat. This did give us both solutions, guys. They did give us both solutions. The key thing, that was bare long. It was indeed bare long. I'm going to show the original question for a second. I'll scroll up for a second, guys, just so you can see what we were working through. It's a pretty good question, guys. Quick recap of this question. Okay, just the key ideas that we had to use. So we saw we had two tangents. We wanted to find equations for these tangents. Because they're tangents and they intersect the circle at one point, that's going to be one root, okay? There will be one root if we were to sub in our line equations into that x equations. If we have one root, what does that mean? The discriminant b squared minus 4ac will be equal to 0. So we use that point of 5, 0. We use the point of 5, 0. We plug in the straight line equation with that unknown gradient. We don't know the gradient. Put that into our circle. Put it into the discriminant. Then from there, we do the b squared minus 4ac and find the values of m that would satisfy it being equal to 0. Does subbing in for x always make it cleaner? No, it does not. That's the hard part of this question. Key part is we were given, or after we found our straight line equation to be y equals mx minus 5m, the key thing that we did, sorry guys, is we rearranged it to set x equals something. I even started off by making that y sub at the start, showing that if you get to this point in the exam and you have time, do not panic, just try to do it a different way. And this is one possible different way you can do it. And once again, with circle questions, always draw it out if you can. Hope everything makes sense there. How many marks? This will be quite a few marks to be fair. I don't actually have the number of marks for this question, but definitely be quite a few. It'll be towards the end of the paper for sure. Hope that all makes sense, guys. We are on YouTube, guys. We are streaming on YouTube. The recording will be up after as well. Let me know if everything makes sense, guys. Everything makes sense. Thumbs up if you want me to go on to the next question. Thumbs up if you want me to go to the next question, guys. 50 marks? Maybe 50 marks. Give me a thumbs up for the next question. Thumbs up for the next question. We are on YouTube, guys. I'm focusing on the YouTube chat mainly. Can't really see the TikTok too much. Okay, I hope that makes sense. I'm gonna put the next question up, but let me know if you guys have any questions for that. It's a simple trig identity question. Just gonna leave it up for a second. I'm seeing mainly thumbs up for the next question. Let me know, guys. Let me know. See, most people are happy. Most people are happy with this. I hope the videos are helpful, guys. If they are helpful, subscribing to my YouTube would be amazing. Everything's gonna be free this year. Everything is just to try and help you guys out, to be honest. See if we can get you guys A stars. So here's the next question, guys. Nothing too tricky, just a trigonometric identity question. Feel free to have a go. Feel free to have a go. This document and the recording of me explaining will be available on YouTube the second we finish, guys. Okay? And you guys can scroll through if you need any explanations. I'm explaining every question all at once, so if you find it on the YouTube after, you won't see me chatting to chat and interrupting myself. Okay? That's the key idea at least. Unless I see a really good question, I'm just gonna keep on going through everything. Is everyone happy? I'm seeing more people wanting to move on. This document will be available after, guys. So if you want me and the recording, so if you want me to go through it again, you can just watch the recording. But it looks like most people want to move on. So everyone's happy to move on. We have this trig identity question. Remember, guys, trig identities, they love it in the exam. I think we see about 15 marks per average, or on average each year. All right, guys, I'm going to start going through this. Looks like we're happy to start going through this next question. Okay. All right, let's go. So we have a trigonometric identity question, guys. I'm looking at this and I'm seeing there's not really any instant trigonometric identities I can use. However, we're given two fractions. I see these two fractions, I'm thinking to myself, let's put them over the same denominator and simply take them one away from each other. So we're going to multiply our left fraction by cot x on the top and the bottom. And then on the right fraction, we're going to multiply it top and the bottom by cosec x minus 1. We just scroll down so you guys can see the workings. So exactly that. We're going to put each fraction over the same denominator. Cot x multiplied by cot x is cot squared x. Cosec x minus 1 times cot x. We can just leave that unexpanded in the denominator. Then on the right fraction, we multiply the numerator and denominator by cosec x minus 1. We already established that the denominator we're cross multiplying, so it would be the same. So we're not cross multiplying, we're putting them over the same denominator, so those will remain the same. Cosec x minus 1 multiplied by cosec x minus 1, that's just going to be cosec x minus 1 squared. They're over the same denominator, so we can rewrite this and we can expand out the squared brackets. So cosec x squared or cosec x minus 1 all squared. Cosec x squared is cosec squared x. Then we're going to have minus 2 cosec x, because we're going to have 2 times minus 1 cosec x, which is minus cosec x. 2 of those minus 2 cosec x. And then minus 1 squared is just going to be plus 1. So we have cot squared x, take away, then all in brackets, cosec squared x minus 2 cosec x plus 1. So we're going to be taking away that cosec squared x. We're going to be adding minus minus, adding 2 cosec x, take away 1, okay? From here, guys, we're going to be using a trigonometric identity. For asking these questions, we're going to be using trigonometric identities. Now type it in the chat if you want, but the key trigonometric identity that links cot squared x and cosec squared x, we have 1 plus cot squared x equals cosec squared x. Now it doesn't actually matter which substitution you make for this question, you will get the right answer either way. But I'm going to sub in 1 plus cot squared x for our cosec squared x. So we're going to have cot x take away 1 plus cot squared x, that's all in the brackets, plus 2 cosec x minus 1. Okay? So we have cot squared x minus 1. We also have cot squared x minus cot squared x. Those two will indeed cancel out. So we're left with minus 1 plus 2 cosec x minus 1. So that's 2 cosec x minus 2, all over the same denominator. Don't worry about that just yet. All over the cot x multiplied by cosec x minus 1. Okay? So then from here, we're not done quite yet. We are trying to get to tan x. It's not letting me scroll down. Okay. So all we're going to do is we're going to factor out that 2 from that 2 cosec x minus 2. The reason we're doing this is because we can cancel out something from the numerator and the denominator. So factoring out the 2, we have 2 times cosec x minus 1. Quickly see, numerator, denominator, these cancel out. Bing bong. So we have 2 over cot x. Remember, cot x is 1 over tan x. Okay? So 2 over cot x will be 2 over 1 over tan x. Okay? So 1 over tan x, denominator of a denominator, slap it up to the numerator, that's 2 tan x. And we've shown that the left-hand side is equivalent to the right-hand side. There's a question again. I'm going to leave the workings up for a second. This is Edexcel, guys, Edexcel maths. So that was all the explanation in one place. Let me know if that all makes sense, guys. Let me know if that all makes sense. Ask any questions if you want, guys. Any questions if you want. I'm going to leave this up for a second before we move on. Just let me know, guys. Let me know if you have any questions. Are we all good? Are we all good? This is Edexcel maths, guys. Edexcel maths. Make sure the YouTube is still running. I'm always a bit paranoid. Okay. Yeah, this is not too bad of a question. It would most likely even be a part A of a longer question. But you know, maybe 3 or 4 marks. So always valuable marks, could get you the A or the A star. So definitely important. The thing is, with this, getting everything to sine and cos, I haven't tried it. You would assume it would mathematically work, but there's just no point. We have a trigonometric identity that connects cosec squared x to cot x, and we also had what we're trying to get to in tan. So it feels like going to sine and cos would just make everything a lot longer and a lot harder. You could give it a go. I haven't given it a go. I just kind of went through it with the simplest and most efficient way possible. Because remember, we are under time pressure in that exam. Okay. This would be a first part to a hence question. That's exactly what we do. That's exactly what it would be. This would definitely be the first part to a longer question. It's still tricky, guys. People might get stuck. They might freeze up about the trigonometric identities. Just use what you know in these kind of questions. Guys, we are streaming live on YouTube. My webcam is on YouTube. So don't worry, I haven't disappeared or anything. So give me a thumbs up, guys, if you want the next question. Give me a thumbs up. Thumbs up if we're happy to move on. The YouTube chat is slow, so I'm sorry if I'm repeating myself while we wait. I'm going to put the next question on the board. On the board, sorry. Yeah. Well, we've already gone through 1, 2, 3, 4. We've gone through 5 questions already, guys. We've been very efficient today. It's actually the last question, guys. Last question. I'm seeing thumbs up. What topic makes candidates get low marks? Whatever they choose to put at the end of the paper. We've done vectors, guys. We've done 2 trig identity questions. We've done circles. We've done differential equations and a bit of partial fractions. This document and the recording will be available after. This document will be available in my bio. And like the same way that the Sunday and the Saturday document is available, and the YouTube recording, this will be on YouTube afterwards. I'm explaining all the question at once, so you can get all the explanation at once, and then I'm answering questions in the chat. I see a lot of thumbs up in the chat, so it looks like we're all good. I'm just going to leave this modulus bit on for just a second before we continue on. Everything will be shared after the live stream. I'm seeing a lot of thumbs up on YouTube. Sorry if I keep checking the YouTube, guys, just making sure everything's all good. Okay. So we have done 5 questions. We have one more, guys. We've done 2 trig identities. We've done circles, differential equations, and a hard vector question. It's the last question we're going to do today, realistically. Okay, I've seen mainly thumbs up. Might have to send it now on this last question. We have a modulus question. We have a bit of range, bit of plugging in. One of those weird limitations of the models. Quite a good question here. Guys, more thumbs up in the YouTube chat. I'm seeing all thumbs up in YouTube. Seeing everyone happy. This question's fine. This question's fine, guys. If you just take it step by step, it's all fine. Looks like we're ready to go. Looks like we are ready to go, guys. You're not cooked, guys. You are not cooked. You'll be fine. We are on YouTube if you want to see my beautiful face. We are on YouTube. We are on YouTube. Link in bio. So I might quickly put that in the. That's all good. It's all good. All right, let's go through this question, guys. I'm just gonna ask this one question. Could they ask questions on arc cos and arc sine? They could. They definitely could. They definitely could. You can also see second derivatives. That could definitely be a harder thing that they put in. But if you guys know it and you've practiced it, you're all good. It looks like many people are happy to move on. All right, let's go, guys. Let's go. So we're told the number of members at 2 gyms is being tracked over time. The number of members at gym X, we're going to have 2 gyms, gym X and gym Y, okay? The number of members at gym X in hundreds, remember that in hundreds, they're going to want you to use the units, is modeled by mx, for gym X, equals the modulus of t minus 4 plus 6, for t larger than or equal to 0. The number of members at gym Y in hundreds is modeled by my equals 10 minus the modulus of 3t minus 9, for t larger than or equal to 0. T is the number of years since the gym opened, okay? The graphs of mx and my are shown over a 6-year period. I have the graphs later on in the question, guys, don't you worry. Part A, find the initial difference between the number of members at gym X and gym Y. I saw it in the chat already. We're going to plug in t equals 0. Because remember, t is the number of years since the gym's opened. When the initial difference, t must have been 0. So what we're going to do for part A, nothing too tricky, plug in t equals 0. Here's the graph, guys. I have it even better drawn out. Give me a second. So we have our mx of t, be the modulus of t minus 4 plus 6. They give you this in the question, guys, so don't stress too much about the drawing. And my of t equals 10 minus the modulus of 3t minus 9. Looking at part A of that initial difference, we sub in t equals 0. So looking at our mx of t, we have 0 minus 4. That's going to be minus 4. The modulus of minus 4, remember the modulus sign will get rid of that negative. So the modulus of minus 4 will just be 4, and then we're going to add 6. 4 plus 6 is 10. But that's not 10 people, guys. Remember what it was. That number of members, initial difference to number of members in hundreds. So that's 10, 100, 1,000. Yeah. But don't worry too much about that. Just keep that in your mind in case you have to give the units in the answer. For gym Y, we have 10 minus. We're going to plug in t equals 0. 3 times 0 is 0. The modulus of minus 9 is 9. So we have 10 minus 9. Because the modulus of minus 9 is 9. So 10 minus 9 is just 1. 10 minus 9, we have 9. And I've even said we have 900 members. The key thing to remember to put the units. So the reason we do 10 minus 9 is because we had 10 for gym X and 9 for gym Y. 10 minus 9 is 1. So the difference was 100 members, okay? Oh, sorry, I'm absolutely waffling, guys. Sorry. We have 100 members at gym Y at the start. Find the difference. We do 10 minus 1. It's 900 member difference. Sorry. Stumbled on my words there, but all the working here is correct. Now going on to part B. I'm only human, guys. When t equals t, so some unknown t that we're going to have to find, gym X introduced new classes and the number of members began increasing. So what are we thinking, guys? This is going to be looking at where the lowest point of our graph for gym X is. We have to suggest a value of t, giving a reason for your answer. So let's think about it, guys. Because we're going to start increasing with gym X. Remember, looking at our graph, is mx of t. We're decreasing in members, decreasing. New gym classes. In other words, we've got to the minimum point, and now we're going to start increasing our number of members. So we're going to get positive. So all we have to do is find the minimum of this mx of t. Now to find the minimum, we have something modulus plus 6. We know whatever is in that modulus has to be 0 or greater than 0, because it's going to be a positive number or 0. So the least that can be is 0. So we're going to think what value of t will give us the minimum of mx of t. Well, we know the minimum of this modulus will be 0. And the only way this is equal to 0 is when t equals 4. And then the total value of mx of t, or y, will be 6, because it's going to be 0 plus 6. But don't worry about that. So essentially, we're finding the minimum of mx of t. We see when the modulus equals 0. So the modulus of t minus 4 being equal to 0 means t equals to 4. And that is literally all we have to do for part B. Just find that value of t. Nothing too tricky for part B. Then looking at part C, we have to find the range of values. I know everyone hates it when we say range. We have to find the range of values of t for which gym y, so that my of t, has more members than gym x. Giving our answer in set notation. I know we all love set notation, don't lie. It's an amazing thing. So remember, we are given the graph. We are finding when my of t is larger than mx of t. So looking at the graph, this already gives us an idea of the numbers we're going to be seeing, and we're going to be seeing it's an enclosed range of, in this case, t's. It's not going to be one end or the other end. There's going to be a range, okay? So, scrolling down, all we have to do is compare. We're going to find where the lines cross each other. Now, in my question, I said them equal to each other. It would actually be smarter to maintain this inequality throughout the question. But either way, what we're going to spot is we can see that the negative branch of mx of t, the reason we know it's the negative branch is because looking at this red line going down, that negative gradient, we know we're going to have minus t. So looking at the negative branch, when that modulus of t minus 4 will become minus t plus 4, the negative branch, this will intersect with also the negative branch of our my of t. Okay, we know this because my of t would be minus 3t minus 9 if we just expand out the positive version of this modulus. But because the positive version would be minus 3t, the gradient would be minus 3 if this was the positive branch. So therefore, we see the negative branch will intersect with the negative branch as our my of t has a positive gradient. Therefore, it's going to be minus 3t. We'd have to take the negative branch inside. I hope this is making sense. And then we also have the negative branch of mx of t. This is the point where these two will intersect. And we also look, the next point of intersection we see is the reflection of both of our modulus graphs. So these will both be the positive branches. So let's compare the two and see where these two modulus graphs intersect. I would once again recommend maintaining that inequality, not an equal sign. But the key idea is how to solve this. So that's what I'm going through. So looking at this negative branch intersecting the negative branch, we're going to turn that modulus of t minus 4 to be minus t plus 4. Okay, so we have minus t times, minus times t minus 4 plus 6 equal to 10 times minus, and then that modulus of 3t minus 9 will be minus times 3t minus 9, or minus 1 times 3t minus 9. Okay, so we have minus t plus 4 plus 6, and then we have 10 take away minus 3t, then minus 1 times minus 9 is going to be plus 9, okay? We have plus 4 plus 6, that's going to be plus 10 on the left-hand side. Then we have 10 plus 3t minus 9, because we have minus 3t, so it's going to be plus 3t, and then minus 9, okay? 10 minus 9, that's just 1. So we have minus t plus 10 equals 1 plus 3t. Therefore, add over the t on the right-hand side, take away the 1, we have 9 equals 4t. Divide over by 4, we have our first value of t where the negative branch intersects the negative branch for each one. So that first intersection on the most left, t will be 9 over 4. Okay? Because we are live on YouTube, Now we're going to compare the positive branches. Okay? Oh, document is spazzing out a bit. Okay, there we go. So now, because we saw the other point, we'll be checking the positive branch of each modulus function. Okay? So checking the positive branch of each modulus function, we're going to set, sorry guys, t minus 4, so we keep that t minus 4 positive within the modulus. We have t minus 4 plus 6 equal, and then we keep that 3t minus 9 the same. So we have 10 take away, then in brackets, 3t minus 9. So minus 4 plus 6, that's just plus 2, 6 minus 4. Then we have 10 take away minus 9, minus minus, it's going to be plus. So we have 19 minus 3t. Bit of rearranging, take away 2 from the right to get 17. T plus 3t is 4t. So our other value of t will be 17 over 4. This is 4.25, okay? So we looked where they intersected on the negative branches, the reflective branches, and we looked at the positive branches. We split this up into two different sections, okay? So the key thing, the reason why we should have kept the inequality is because this would have shown us the values of t that would have had to be larger than 2.25, or this 9 over 4, and less than 17 over 4, 4.25. But the other way you can see it is because we have this area of our graph, or this section of our graph, where gym y, or my of t, is larger than mx of t, we can see it would just be these range of values. Now going through the set notation very quickly, all this means is we have the set of t's, that's what the squiggly bracket means, it's the set of t's, such that, that's what the colon means, and then you can just write out your inequality that you found. No, you can write it as a fraction, guys. Now, last part of this, you can write it as a fraction or write it like this, either way is fine. Now, I'm sure you guys already saw the answer, but the document is lagging, guys. I apologize. Apologize if we crash. Looks like we're all good, okay. Now, part D of this question, state a limitation of the model used for gym Y. Now, you can literally just look, I hate these 1 markers, guys. I'm sure you hate them too. They're just stupid, but they are only worth 1 mark, so it's fine. The key thing we have to spot is gym Y eventually gets a negative number of members. Okay, we can see that graph goes below the x-axis. We're going to get negative y's. So we know that just doesn't make any sense. It's all logic here. So the limitation is we can see that my of t becomes negative, and we can't have a negative number of members. It's not realistic. Okay. So let me know if you guys have any questions. Let me know if you have any questions for that. It's Edexcel maths, guys. Edexcel maths. You'll be fine. You'll be fine. We are on YouTube, guys. We're on YouTube. That's where my face cam is and everything like that. Let me know if that all makes sense, guys. Let me know if that all makes sense. Can I show the question? I got you. Exactly. Gym member can't be negative. Sorry, guys. YouTube chat is really slow for me. I can't show the whole question in one go. So we were given this. That's the first part of the question. We did do a rate of change question at some point. There's the question, guys. Part A wanted the initial difference. Can I assume the yeah? You could assume the you could say the model assumes limitless growth. The key thing is that it's logical. Oh no, sorry, because they wanted gym Y, not gym X. Gym X, you could assume that you could have an infinite number of members, which makes absolutely no sense because your gym is only so big. But they wanted gym Y, and gym Y goes negative. So that's the key thing for gym Y. In set notation, when do you use a union or an intersecting symbol? Union or intersecting. Okay, so because in this case it was a range of values, so we had our t's in between two values, that would all be the intersection. Okay. But if we had that t, imagine we were thinking the values of x, yeah? This would be all the way to the left on one side and then on the right on one side. It wouldn't be a range of x within a small point, it would be everything to the left and everything to the right, not including that range. In that place, sorry, we'd have a union because it would be these values of x or these values of x. Could I go over B quickly? So B was asking the time after this new class, which made GymX amazing. When T equals T, GymX introduced new classes, so it turned very good. People started joining again. We had more members. Number of members began increasing. Suggest the value of T. This would simply be the minimum of mx of T. Because we see we're at our GymX, we're losing members. Then at this point, something must have happened, and then we're going to increase. The minimum that this modulus function can be, well, we know the minimum of just in isolation of this modulus function of t minus 4. Exactly. We know the minimum of this t minus 4 will be when it equals 0. Because the smallest number a modulus of something can be is 0, or a positive number. So the smallest number of our function of t for mx of t will be when this modulus is equal to 0. You don't even have to state the value, you just have to state the value of t when this equals 0, because that's the smallest that the modulus can be. And because we're adding 6, it's only going to get more positive. The graph was given for this question. Looks like we're all good. Go on YouTube, guys. My face cam is on YouTube. I haven't disappeared today. Guys, if you subscribe to the YouTube link in bio, I'd be eternally grateful. That'd really help me out. I hope everything makes sense, guys. I hope that all makes sense. Give me a thumbs up if that's all good. And we're going to be ending at 9:30, guys, or until my laptop crashes, whatever comes first. Hope that all makes sense. Hope that all makes sense. Sub, bro, thank you, guys. I really appreciate any subs are really appreciated. I'm gonna keep these streams coming. How do I know what type of integration to use? I mean, they will tell you if it's substitution. If you have your function of x differentiated on the numerator and the function of x on the denominator, then we're going to be using the natural log. Especially if it's a partial fraction question, we know we're going to be using the natural log. Integration by parts. You have two things multiplied within an integral, or two functions of x, sorry, multiplied within an integral. We're going to be using integration by parts. Implicit, if we have a function of y, that's differentiation. Sorry, I'm awful. I have a good implicit differentiation question for tomorrow, guys. I think we're done with YouTube here, guys. I think I'm going to end the YouTube stream here. We've done 6 questions. Vectors, trig identities, differential equations, circles, trig identities, and modulus. What I'm going to do, guys, sorry, I'm going to upload this on YouTube, and I may potentially just go on TikTok for half an hour just to go over this circle question again, because I had a lot of questions about that, and maybe some predicted topics. This is Edexcel maths, Edexcel maths. I hope that all makes sense, guys. I'm going to quickly scroll down to the very bottom. Oh, sorry, very top, sorry. So here's some predicted topics. We're going to be ending the stream in a couple minutes. All this is, guys, is the topics that will come up every single year. We see the number of marks every single year for each topic and the mean number of marks on the right-hand side. I hope this was helpful on YouTube, guys. I hope this was helpful. Just went through a few hard questions. I'm going to be ending the YouTube stream just so I can upload all of this quite condensed and not too long. So thank you for joining on YouTube, guys. I'm just going to end the stream now. Cheers, guys. Cheers. I'm still on TikTok live, though. So I appreciate everyone on YouTube. Any subs on YouTube are very helpful.